Okay, it seems like I must have hit the stop record button or something last time because we only got half a video. So I'm going to talk a little bit about 4.4 stuff again. We'll go through it a bit more quickly, but I do want to talk about that a little bit. And then we'll get to some questions. So So 4.4 it's about convexity and the second derivative and how that looks with graphs. And the first derivative is the rate of change, so f prime. And this is associated to slope, right? Okay. F double prime, that's the rate of change of the rate of change. So it's associated to the change in the slope. Which means it's associated to curvature. And that word means something very specific in Calc 3, but we'll just call it curvature here because it sort of fits. I'll also say convexity. Okay. So let's look at a couple graphs, 4 of them to prove. We'll look at that one. We'll look at that one, and that one. Okay, this one is increasing. These first two are increasing, right? And these two are decreasing. Their slope is negative. Okay, this one, it starts out really steep and gets shallower, right? I have a big number for my slope here and a smaller number for my slope here. So the second derivative, the rate of change of slope should be negative. The slope's decreasing. So this is f double prime is less than 0. This one, it starts out pretty flat and then it gets steep. So the second derivative must be positive because the slope is getting bigger. This one starts out flat and gets more negative, right? So not very negative slope. So this one is f double prime is less than 0 again because the slope is decreasing. Not that it's getting shallower, but that it's getting more negative. This one starts out very negative with its slope and isn't as negative. So yeah, you can see that dot. Okay. So this one is f double prime is bigger than 0. And those are kind of the 4 building blocks for any function. The graph of any function that's 2 times differentiable. You get kind of quarter circles everywhere that are stretched or squished together a little bit, but the general shape is this. Okay, if we put this together, I have 2 half circles. This one, the slope starts out really big, goes to shallow, and then becomes big negative. So all through this, the slope is decreasing. So this one has f double prime is less than 0. This one, it starts out really negative, ends up really positive, and it goes through 0, right? This one, the slope negative, not as negative, 0, more positive, really positive. So this one, the second derivative is bigger than 0, okay? This is concave down. And this is concave up. One other graph that we should draw, well, two other. Well, we can do a couple. I was going to say we could do a couple more, but I don't actually. Yeah, we're good. Okay. At some point in here, about right there, and at about some point in here, let's say about right there. On this side, it's concave down, but on this side, it's concave up. Where it switches from concave down to concave up, this is a point of inflection. Here, it goes the other way. This is concave up. This is concave down. At the point where it switches from up to down, we have a point of inflection. These are where F double prime switches through from greater than 0 to less than 0, or vice versa. Okay. But typically, this is where so possible points of inflection, that's where F double prime equals 0 or F double prime is undefined. Just like we found critical values, that's the same way you can find points of inflection, right? You look where the second derivative is undefined or 0 instead of where the first derivative is undefined or 0. Okay. Go back to this picture. On this picture, there's some place at the top where F prime is equal to 0 there, right? And there's some place on the bottom here F prime equals 0. So with this picture in mind, we get a second derivative test for extrema. If a function has a point C with F prime at C equal to 0, then CF of C is a local max if F double prime at C is less than 0, a local min if F double prime at C is bigger than 0, and a point of inflection if F double prime of C equals 0. Okay. So I have a derivative there, and I have a second derivative there, and I can compare the second derivative to 0 and figure out what that sort of maximum or minimum or whatever that is. Okay. That's called the second derivative test. think that's everything from the section that I want to talk about sort of theoretically. I misspoke on this one. Never mind. It's not necessarily that it's a point of inflection if f double prime is 0, right? We did that example yesterday. Is inconclusive. Doesn't tell you much. Right. So x squared equals f double prime, which is 0 there, and it's 0 there, but that's definitely not a point of inflection. Concave up, concave down, points of inflection. Good. Okay, what questions do you guys have? What problems do you guys want to work? That type of stuff today. Yeah. Okay. Okay, so we've got this periodic function 4 times e to the sine of x over 4. We want to know where its extreme values are and what they are. Okay, so f of x is 4 e to the sine of x over 4. So f prime, we use a chain rule. Twice, right? Repeated chain rule. So we get this as our derivative. 4's cancel, that's kind of nice. Okay, and to find critical values, I want to know where this is undefined. Cosine's defined everywhere. X over 4 is defined everywhere. Sine's defined everywhere. E to something is defined everywhere. So it's defined everywhere. There's no issues about domain. So for the critical values, all we have to do is we have to figure out where it's 0. And it's going to be 0 if e to the sine of x over 4 equals 0, or if cosine of x over 4 equals 0. This one, e to something, no matter what that thing is never 0, right? So this has no solutions. This one, we do have solutions. Okay, I'm going to go around the circle a fourth as fast, so it's going to take me a lot longer to get around the circle. But what I want is I want the cosine of x over 4 equals 0, which tells me that x over 4 equals, well, cosine is 0 at pi over 2, 3 pi over 2, that sort of thing. Odd numbers of pi divided by 2. So 2k plus 1, those are odd numbers, right? And so to get that's for integer k. So to figure out where x is, I'm just going to multiply by 4. Which is, 4k plus 2. Which we could write as 0, 2 pi, 6 pi, plus or minus these things, right? So those are the places that we would be looking for our zeros. Maybe that one. No, these are actually, I don't get the 0 one, do I? Because if I put 0 in there, I get 2. So I get all of them that are 4 apart. So I bet that the maxes are 8 apart, because that one is 4 pi away from that one, which is 4 pi away from that one. So the top ones are 8 pi apart. Okay. So now we have to do figure out which one's the maximum, and because it's periodic, I get to add the period to it. The period's going to be 8 pi. So 8 pi times k is k periods to something. So it's going to be this one. And the maximum value, well, the maximum that the sine can get to be is 1. So the maximum e to the sine can be is just e. And then I multiply it by 4. So the maximum it will be would be 4e. Let's do this. Max of the sine function max e to the sine function max of f of x 4e to the sine x over 4 is going to be 4e. All good with that? So we will put in 4e, and it occurs, well, this happens when the sine of x to the 4th is 1. Which of these give me sine of x to the 4th is equal to 1? Sine of a 4th of x, not x to the 4th. Sine of a 4th of x for the 2 pi over is the sine of pi over 2. And that's equal to 1, right? Sine of 6 pi over 2 is the sine of 3 pi over 4. I want that over 4. 3 pi over 2. This is -1. So the 2's are good, or at least the positive 2 is good. And then 10 will be good. And then 18 will be good, and something like that, right? So we're going to start out with 2 pi in here. And then that period, we found one maximum. The period is 8 pi, so that will give you the next one, and the next one, and the next one. The period's still the same. So we're still going to have the minimums occur every period. So I'm still going to go with the 8k pi being the difference between the periods. The minimum of the sign is -1. So the minimum of f of x is 4 times e to the -1, because that's the smallest e will be, e to the power will be. So we'll put that in there. Which is the same thing as 4 divided by e. And this will be, well, I just have to pick one of them. We found one where it's a minimum, and that was at 6 pi. So there's my minimum. It happens once at 6 pi, and then because it's periodic, if I add 8 pi to it any number of times, I find another minimum. Questions on that one? Okay. Other questions you have on 4.3 or 4.4? Let's do this one from the book. It gives me a pair of x-axes. This one is labeled with f prime. It's got a point at -2. It's got a point at 0. And it's got a point at 2. Extend this a little bit further. It says that f prime is positive here, negative here, positive here, negative here. And then it gives me another x-axis for f double prime. And it tells me I have 2 points, one at -1, one at 1. And f double prime is negative here, positive in here, and negative in here. It passes through the points. Through -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. Okay, and it wants us to graph this. So let's do that over here. Has to go through negative 2, 2, negative 1, 1, 0, 0, 1, 1, and 2, 2. So I have to have those points on my graph. Okay. Okay, below 2, I have to be increasing and concave down. So below 2, I have to be increasing and concave down. Means my shape is going to be that shape, right? Of the 4 quarters of the circle, this is the one that's increasing and concave down. Decreasing concave down, increasing concave up, decreasing concave up. Right? So this is the one that we want to put here. I'm going to kind of put these guys together a little bit so that they are on the same number line. Okay. Let's do this. Plus minus. In here, it is minus on top, minus here. Between the greens, I'm minus and plus. I'm plus and plus. This is plus and minus, and this is minus and minus, right? Okay, so I'm going to have 1, 2, 3, 4, 5, 6 pieces that I have to deal with. The next piece on the graph is minus and minus. Minus and minus is this one, right? This one's minus, minus. This one is plus, plus. This one is minus, plus. This one is plus, minus. For top one's the first derivative, bottom one's the second. So this one being minus, minus is going to look like this quarter of the circle. So it just continues down to there. And the next bit, I've got minus and plus, which looks like this one. So it's that quarter of the circle. Between 0 and 1, I'm plus and plus. So it's that one. Between 1 and 2, it is plus and minus. So it's that one. And then after 2, it's minus and minus. So it's that one. So our graph looks like that. Questions on that? Just kind of organization there to kind of get everything together. Right? Not too bad. Let's find an inflection points. So it gives us this derivative and it tells us at what points, if any, does the graph of f have a local maximum, minimum, or point of inflection? Okay. So first, let's do our first derivative. Where does this have zeros? It has zeros at 1 and at 2, right? Okay. If I plug 0 into this, I get negative 2. So on this interval with the test point of 0, it's going to be 0. When I cross with my x value from lower than 1 to bigger than 1, this is the factor that changes signs, but because it's squared, it doesn't have any effect on the sign change. So this is also going to be negative. As I cross 2, this is the factor that changes signs. That one has a exponent of 1, so there will be an effect on the sign change, so it becomes positive. Good with that? Okay. So here's my first derivative sort of outlay. So it's decreasing, and then it's still decreasing, and then it turns to increasing. Okay. So where do I have a possible max or min? At 2, I would have a possible minimum, right? Going down and going back up. That is a minimum. So we've got a minimum here. Okay. How do I figure out points of inflection? Yep. So to take the second derivative, we use the product rule. So it's going to be x minus 1 squared times 1 plus x minus 2 times 2 times x minus 1 times 1. Which is equal to x minus 1 times x minus 1 plus 2 times x minus 2, which is x minus 1 times 3x minus 5. So this is equal to 0 at x equals 1 or 5/3. Good. So on our second derivative line, put in 1, put in 5/3. If I put in 0, I get a positive 5. So this is positive here. As I approach 1, this is the factor that switches. It only has an exponent of 1, so it will switch signs there. As I approach 5/3, this factor switches, and it will switch there. Good with that? So where do we have points of inflection? Both of these switch from positive to negative or negative to positive where the second derivative is 0. So these are both points of inflection. Questions on that one? Anything else you guys want to talk about? I kind of think these last two sections are fairly straightforward. Just take some practice on doing some of this stuff. But we're still pretty early. We talk a little bit about L'Hopital's rule, but then we're getting way ahead. Anybody online have some questions that they want to ask? Yeah. these guys? Up. These ones? Plug it into the second derivative. Yeah, if I'm looking at so if you're looking at concavity here for points of inflection are where the concavity changes from up to down. And so you want to know the value of the second derivative, if it's positive or negative, to tell you about the concavity. Other questions you guys have? Oh, it is Friday. I told you I wasn't going to keep letting you guys out early, but yeah. I will see you guys next week.